I saw a video on YouTube that showed what it would look like if you put everybody on Earth into a big pile. I wanted to see what that math would look like, so this is what I got. I've done 2 or 3 versions of this video already, and each time I try to make it shorter and simpler, so this might be the 3rd version. So starting out with the logic here, all people on Earth in a cube. I'm going to say that the average maximum age might be around 80 years old. So approximately 1/8 of those people will be under 10 years old and thus have a child or infant weight. So the far majority of people will have an adult weight. So just to average this in, I'm going to use the low end of an adult weight, so say 130 pounds. But feel free to do whatever specific math you want to hone in on a more accurate number. So 130 pounds, 2.2 pounds per kg, comes out to be approximately 60 kilograms. For this next equation, I'm going to give people the same density as water, which will be 1 kilogram per liter. And that's because if you put a person in water, they tend to be neutrally buoyant, neither sinking nor floating very well. About 8 billion people on the planet, 8 times 10 to the 9th P. One person will be approximately 60 kgs. 1 kg equals 1 liter. Gives you approximately 4.8 times 10 to the 11th liters for every man, woman, and child on the planet. I want to turn those liters into cubic meters so I can have a distance in meters on each side of the cube. So here's 1 cubic meter. This is where it gets a little difficult to explain, but this 1 cubic meter is 1 meter in each dimension, and 1 meter is 100 centimeters long, and 1 liter is 10 centimeters in each dimension. So what we're looking at here is 1/10 of this distance for this whole meter. 1/10 of that will be a liter. It'll be 10 centimeters by 10 centimeters by 10 centimeters, gives you 1 liter. And 10 centimeters across right here is 1/10 of that distance. So it's going to be your little liter jugs here. You're going to have 10 going that way, 10 in that dimension, and 10 in that dimension. 10 times 10 times 10 is 1,000 liters per cubic meter. But long story short, 1,000 liters per 1 cubic meter. We'll come over here, take our 4.8 times 10 to the 11th liters to represent all of our people on the planet. That's how many liters we have. 1,000 liters per cubic meter gives you that many cubic meters, 480 million. Let's take the cube root of that, 480 million. That gives us 783. So there's 783 meters in each direction. 783 meters is the same thing as 0.78 kilometers. I'm just going to round that to 0.8 kilometers here, since these are all just averages or rounding numbers. 0.8 kilometers, 1.61 kilometers per mile. I should not have written M there because M means meter. So mile, that means it's about a half a mile approximately. So this 0.8 kilometers that goes from here to here, approximately half a mile. I'll use the Grand Canyon here as an example because I think that's what I saw in the video on YouTube. Grand Canyon goes up to 18 miles wide, average width though, approximately 10 miles, average depth about 1 mile, according to Google on those. I don't stand behind those numbers. Draw a scale representation here of the Grand Canyon in centimeters. I know I'm switching between centimeters and miles or metric and imperial, but whatever. So 10 centimeters across represents 10 miles. 1 centimeter deep represents 1 mile deep. Draw our cube of people, which will be a half mile by a half mile in all dimensions. So 10 miles across, 1 mile up. And I drew a little cube there that's a half a mile in each dimension. So that's what it'd look like if you put everybody into a cube at the bottom of the Grand Canyon. This pile is smaller than what I expected, maybe what most people expected, because 8 billion people on the planet is a lot. But it does go about a half mile high, which puts it at one of the tallest buildings on the planet. and a half-mile wide is pretty wide. But when you compare it to the Grand Canyon here, makes it look like that the Grand Canyon is really large or that pile is really small.